Hello everyone, my name is Ryan Horrible, and this is going to be my video on projectile movements for Mr. Murphrey's Fundamental of Physics class for June 2014. So what we're going to do, we're going to start off here and actually tell you what a projectile is. A projectile is going to be any object projected with the exertion of force. Now projectile movement is defined as a form of movement in which an object or projectile is launched near the Earth's surface and it moves along a curved path. And that path is going to be called a parabola. Let's start off with Sir Isaac Newton. Everyone thinks that Sir Isaac Newton discovered gravity. Newton never actually discovered gravity. He discovered the fact that it was universal. Aristotle believed that stars, planets, and the moons moved in divine circles, and he never needed a reason to explain it, never wanted to know why. But Newton, on the other hand, he recognized that if there was nothing acting on the stars or the planets or the moons, then they should just move in a straight line. They shouldn't be able to move in a circle. Newton realized that gravity of every planet would be directed to one fixed point. That is the reason why an apple actually falls down off of a tree and it doesn't fall away from the tree. It just falls straight down to the center of the earth. Gravity acts on an object in only one direction, vertically. And what it does, it accelerates it in one direction down towards the center of the earth. Basically what that means is that there's no effect on it horizontally. So it's not going to change the effect or speed of anything that's moving horizontal. Now because gravity doesn't affect anything horizontally, if you throw a ball at 5 meters per second, that ball is always going to be going vertically at 5 meters per second no matter what. The only thing that's going to affect it is going to be the gravitational force, and like we were saying before, that's going to be 9.8 meters per second, pulling that ball down towards the center of the earth. Now if you want to find out the speed at which that ball is actually falling, you can take the gravitational force, which is 9.8 meters per second, and multiply that by the amount of seconds that that object was falling. So for instance, if you are watching something and it's falling for, say, about 5 seconds, you count 1, 2, 3, 4, 5. What you can do, you take that 9.8 meters per second, multiply it by 5 seconds, and that's going to come out to be about 49. That 49 is going to be the speed at which that ball was falling. It's going to be falling at 49 meters per second. Now going back to the horizontal versus vertical. Like we were saying before, gravity has no effect on anything horizontally. It only pulls it down vertically. Now as you can see here in this picture that I took this afternoon, that piece of wood that goes across the screen is basically just defying gravity, we'll say. It's not allowing that ball to fall down towards the center of the earth anymore. It's acting like a constant, we'll say. So with that ball being rolled, it stayed at the same speed the entire time that I rolled it across that piece of wood. Nothing changed because gravity doesn't affect it horizontally. Now vertically, on the other hand, when I was throwing the ball off my back deck before, you can see that it actually arches. The horizontal speed is going to be the exact same thing from the moment it leaves my hand, but it's actually going to be falling at 9.8 meters per second the moment it leaves my hand because gravity is just going to pull it down towards the earth. Launch angles are going to be the angle at which the object or projectile leaves, for instance, my hand or whatever it's actually launching from. Those launch angles will always equal 90 degrees. So for instance, if you launch a ball at 5 meters per second at 75 degrees, it's going to hit the same exact spot on the ground if you launch it at 15 degrees at the same 5 meters a second. Same goes with 60 degrees and 30 degrees. Now with 45 degrees is going to be the best angle you're going to want to launch anything at to get the maximum distance. Now when it comes to satellites and anything that's orbiting the Earth, like we were talking about before, the gravitational pull is 9.8 meters per second towards the center of the Earth. For anything that is going to be orbiting the Earth, it has to be traveling at 8,000 meters per second. Because what happens is every 8,000 meters of the Earth's surface, it's going to drop in 5 meters. So for that actual object to stay in space or stay in the orbit of the Earth, it has to be traveling at 8,000 meters per second to counteract that 5-meter drop. If you want it to be able to leave the solar system, it's going to be having to travel at 42,500 meters per second. Now, if you want it to actually be able to just leave Earth's orbit, it needs to go at about 11,200 meters per second. In conclusion, Newton never discovered gravity. Newton discovered the fact that it was universal, that it affected everything. If it was on Earth, if it was on Mars, if it was on Venus, if it was out in space, gravity affected everything. Gravity only affects objects that are in a vertical direction, has no bearing on anything horizontally. So, for instance, you throw the ball at 5 meters per second. Horizontally, it's going to be staying at 5 meters per second for the entire time until something stops it. But gravity is going to be pulling that same ball it's going to be pulling the same ball down at 9.8 meters per second squared. Once again, to find that out, you're going to just take the amount of time that the ball is actually falling, multiply it by gravity, which is 9.8 meters per second, and that's how you're going to find out the actual speed at which that ball was falling. So you have a ball that takes 10 seconds to hit the ground. You're going to multiply 10 by 9.8 meters per second, and you're going to get 98 meters per second, and that's going to be the speed at which that ball is actually going to be falling. For a satellite to remain up in Earth's orbit, it has to be traveling at 8,000 meters per second. For it to leave Earth's orbit, it has to be traveling at 11,200 meters per second. And for it to leave the gravitational pull of the solar system, it has to be traveling at 42,500 meters per second. I hope you guys learned something today for my video for Mr. Murphy's Fundamental of Physics class. Once again, my name is Ryan Horrible, and hopefully we'll be doing another one of these, and I will see you guys next time.